Jerry Amon was not supposed to be the one who found it. He was just a volunteer, a professor who gave his spare time to a project most of the scientific establishment considered a long shot at best and an embarrassing waste of resources at worst. He was not sitting at a console in some gleaming NASA facility surrounded by blinking lights and colleagues in lab coats. He was at his kitchen table, a few days after the fact, going through a stack of computer printout paper, the long, perforated kind that accordions into a pile on the floor as you read through it, looking at columns of numbers and letters that represented radio signals the Big Ear telescope in Ohio had been collecting from the sky. It was the kind of work that sounds exciting in theory and is, in practice, deeply tedious. Pages and pages of data, column after column of characters, most of them ones and twos and the occasional three, background noise, faint signals, the radio hiss of the universe going about its ordinary business. He had been doing this for a while. It was August 1977. He was looking for something. He did not expect to find it, and then he saw it. 6 characters in a column. Not the ones and twos of background noise. Not the low, unremarkable numbers that filled page after page of the printout. 6 characters. 6EEQAJ5. A signal that rose sharply from the noise, peaked at an intensity that the encoding system represented as the letter U, so strong the system had run out of numbers and switched to letters, and then fell back down to noise just as cleanly. A perfect rise and fall. A bell curve of signal strength. Exactly the shape you would expect from a radio source moving through the narrow beam of the telescope as Earth rotated. Exactly the shape the signal from a distant fixed point in space would make as the telescope swept past it. Exactly what astronomers had theorized an extraterrestrial radio signal might look like if you were ever lucky enough to receive one. Jerry Amon looked at those 6 characters for a moment, and then he picked up his red pen, and he drew a circle around them. And in the margin, next to the circle, he wrote one word: wow. He did not publish a paper. He did not call a press conference. He did not go on television. He circled it in red pen and wrote one word and kept going through the printout. Because Jerry Amon was a scientist, and scientists do not announce things on the basis of one data point they happen to find at their kitchen table. They verify, they repeat, they rule out alternative explanations, they go back and look again, but the telescope never saw it again. Not that night, not the following night, not in the decades of follow-up observations that came after. The signal appeared once, for the 72 seconds that the Big Ear telescope's beam swept across that patch of sky, and then it was gone. What Jerry Amon circled in red pen that afternoon at his kitchen table has never been found again, by any telescope, by any observer, anywhere on Earth, and we still do not know what it was. To understand why the WOW signal matters, why it has been the subject of papers and debates and books and documentaries for nearly 50 years, you have to understand what was happening in the late 1970s, what the scientific community was looking for, and why this particular signal, in this particular form, from this particular direction, hit so many of the targets on the checklist that the people who had spent years designing that checklist were genuinely shaken when they saw it. The idea that extraterrestrial civilizations might communicate via radio waves is not new. It goes back to at least Nikola Tesla, who in the late 19th century thought he might have detected radio signals from Mars. He had not, though his mistake is more forgivable given what was known at the time about astronomy. The systematic, scientific approach to searching for extraterrestrial intelligence using radio telescopes did not begin until 1959, when 2 physicists at Cornell University, Giuseppe Cocconi and Philip Morrison, published a paper in the journal Nature arguing that radio waves were the obvious choice for interstellar communication. Radio waves travel at the speed of light. They can cross galactic distances. They are easy to produce with technology not much more advanced than what humanity had already developed. And there is a particular frequency, 1420 MHz, the emission frequency of neutral hydrogen, that Cocconi and Morrison argued was the most logical choice for a universal communication channel. Hydrogen is the most abundant element in the universe. Any civilization sophisticated enough to build a radio transmitter would know about the hydrogen line. It was, in a sense, a universal constant, a shared reference point that any technological civilization in the galaxy would be aware of. If you wanted to broadcast a signal that other intelligent beings would notice, you would broadcast at or near 1420 MHz, because anyone listening would be listening there. The following year, 1960, a young astronomer named Frank Drake pointed a radio telescope at 2 nearby sun-like stars and listened. He called the project Project Ozma, after the queen of the fictional land of Oz, distant and exotic and difficult to reach. He listened for a few months and heard nothing obviously artificial. But Project Ozma launched the field of SETI, the search for extraterrestrial intelligence, and Frank Drake went on to become one of its most important figures. He formulated the Drake equation, which is less an equation designed to give a precise answer and more a structured way of thinking about all the factors that determine how many communicating civilizations might exist in the galaxy at any given time. The Drake equation forces you to consider the rate of star formation, the fraction of stars with planets, the fraction of planets capable of supporting life, the fraction on which life actually develops, the fraction of life-bearing planets on which intelligence emerges, the fraction of those that develop communicating technology, and the average lifetime of such civilizations. Plug in the values, and depending on your assumptions, you get anything from fewer than one civilization currently detectable to millions. The equation does not give you the answer. It defines the shape of the ignorance. Throughout the 1960s and early 1970s, SETI struggled for scientific respectability. The mainstream astronomical community was not openly hostile, but it was not enthusiastic. Resources were scarce, and the project had a whiff of science fiction about it that made serious grant-making bodies nervous. The people who pursued it did so partly on faith, a reasoned faith, grounded in the logic of the Drake equation and the Copernican principle that Earth is not special and life here is not unique, but faith nonetheless. They were listening for something they had no guarantee existed, with the knowledge that they might listen for a lifetime and hear nothing, and that hearing nothing would not even prove there was nothing to hear. The Big Ear telescope, where the WOW signal would eventually be found, was part of this effort. Big Ear was a radio telescope at Ohio State University. Not a dish, but a flat reflective surface the size of 3 football fields, with a tilted reflector at one end that focused radio waves onto a receiver. It was designed and built by John Krause, an antenna engineer who had a deep personal conviction that the search for extraterrestrial intelligence was worthwhile. The telescope had 2 receiver beams, 2 separate spots in the sky it monitored simultaneously, separated by a small angle, and as Earth rotated, the sky drifted through these beams. Any radio source that was genuinely out there would pass through one beam and then, roughly 3 minutes later, through the other beam, producing a signal in the first beam and then, a few minutes later, the same signal in the second beam. This architecture matters enormously to the story of the WOW signal, because the signal appeared only in one beam. It rose and fell in the first beam, perfectly shaped, and then, nothing. The second beam showed nothing, no repeat. And this is one of the details that has fueled 5 decades of debate, because there are 2 interpretations of the single beam detection, and they pull in opposite directions. One interpretation is that the signal was a local interference source, a terrestrial radio transmitter, an aircraft, a satellite, that happened to be in the field of view of beam 1 but not beam 2. This would explain the absence of the signal in the second beam. The other interpretation is that the signal was a genuine fixed-point source in the sky, something very far away, and that it simply stopped transmitting or stopped pointing at us, or we rotated out of its beam before the 3 minutes elapsed and our second beam arrived. In that case, the single beam detection is not evidence against a real signal, it is just bad timing. The argument for local interference has always been one of the most serious challenges to taking the WOW signal seriously. But the argument against local interference is also serious, and it comes down to the frequency. The WOW signal was detected at almost exactly 1420 MHz, the hydrogen line. Transmitting at that frequency from a terrestrial source is illegal. The hydrogen line is a protected band. Radio silence around it is mandated internationally precisely because astronomers need to be able to observe it without interference. So whatever produced the signal was transmitting at a frequency that human technology is specifically prohibited from using in that context. This does not make a terrestrial source impossible. Rules can be broken. Military systems sometimes operate in protected bands, but it reduces the likelihood of a human-made interference explanation considerably. The frequency also matters because it was what made the signal so extraordinary when Eamon saw it. The people who designed the Big Ear SETI survey, who wrote the software, set the parameters, decided what they were looking for, had explicitly identified the hydrogen line as the target frequency for the reasons Cocconi and Morrison laid out in 1959. They were listening at 1420 MHz because that was where they thought an extraterrestrial signal, if one existed, would be most likely to come from, and the WOW signal came in at essentially that frequency. It was not close, it was on target. The intensity was also extraordinary. The signal-to-noise ratio of the WOW signal, how far above the background noise it rose, was approximately 30 to 1 point. The background noise level was encoded as 1 in the printout, and the peak of the signal was so strong the system had used up the numbers 1 through 9 and reached the letter U, which represented a level of 30 times the background. This was not a marginal detection, it was not a whisper. For 72 seconds, something was broadcasting at that frequency with enough power that it registered as the strongest signal the Big Ear telescope had ever detected from beyond the solar system. It was, by the metrics the SETI program had set up to evaluate signals, about as good as it was possible to get. The scientists who looked at the data could not explain it as background noise. They could not explain it as instrument error. It was real. It was at the right frequency. It was at the right intensity. It had the right shape, and no one could explain what it was. Eamon himself was careful from the beginning. He was excited. The word he circled says as much. But he was a scientist, and he understood that excitement is not evidence. In the years that followed the discovery, he became arguably the most cautious public voice on the subject, consistently warning against overinterpretation. He would say in interviews and papers that the signal was consistent with an extraterrestrial origin, but that consistency was not proof. That there were other explanations that had not been fully ruled out. That the failure to detect the signal again was itself a serious problem for the extraterrestrial hypothesis, because if a civilization were deliberately broadcasting to us, you would expect them to broadcast continuously, or at least repeatedly, not just once and never again. He sat with the red pen notation he had made in 1977 for the rest of his life without knowing what had made the signal, and he was honest about that uncertainty in a way that is genuinely admirable. He wrote the word WOW. He did not write the word aliens. He was paying attention to the distinction. The search for a repeat detection began almost immediately. Robert Dixon, who ran the Big Ear SETI program, directed follow-up observations within days of the discovery. The telescope was pointed back at the patch of sky, in the direction of the constellation Sagittarius, from which the signal had apparently come. Nothing. More observations followed, over weeks and months. The sky position was observed dozens of times. Other radio telescopes were brought to bear on the same coordinates. The Very Large Array in New Mexico, one of the most powerful radio telescope facilities in the world, was pointed at the right ascension and declination where the signal had originated. Nothing. Year after year of follow-up, decade after decade. New instruments, new techniques, better sensitivity. The coordinates were watched again and again by the most capable radio telescopes on the planet. Not a single recurrence. The WOW signal never came back. This is the central mystery, and it is genuinely hard to explain regardless of which hypothesis you favor. If the signal was extraterrestrial and artificial, a deliberate transmission from some distant civilization, why did it stop? Why was 172-second detection the entire legacy of whatever was broadcasting? If a civilization went to the trouble of building a transmitter powerful enough to send a detectable signal 120 light-years or more through space, and we will come back to the distance question, why would they only transmit once, or only point at us once, or only be detectable for the time it took the Big Ear's beam to sweep past? If the signal was some kind of natural astrophysical phenomenon, a previously unknown type of radio-emitting object, why has nothing matching its profile ever been detected again, by any telescope, in any part of the sky? The distance to the source is itself uncertain because the signal carried no additional information. It was a narrowband signal at a single frequency, a pure tone essentially, not a modulated message carrying data. You cannot determine the distance to a radio source from a single narrowband detection. Astronomers have tried to narrow down the direction, which patch of sky the signal came from, and the best estimates point toward a region in Sagittarius. There are no particularly unusual stars or known objects at the most likely source positions. Whatever the Big Ear was detecting, it was not obviously associated with any catalogued object. This is itself interesting, but it is also uninformative because most patches of sky do not contain anything catalogued and visible in archival data. In 2016, nearly 40 years after the detection, a team led by Antonio Paris proposed an explanation for the WOW signal that briefly generated significant excitement in the media: a comet. Paris argued that two comets, known as 266P/Christensen and 335P/Gbes, had been in the relevant region of sky at the time of the detection in 1977, and that the hydrogen cloud surrounding active comets, called a coma, could potentially produce a radio emission near the hydrogen line frequency. He proposed a test: observe these comets and see if they produce a signal matching the WOW signal's characteristics. He subsequently claimed to have done this and found a match. The comet hypothesis got headlines. It seemed like a resolution, but the scientific response was swift and largely negative. Multiple astronomers examined the comet hypothesis carefully and found serious problems with it. The hydrogen emission from a comet's coma occurs at precisely the hydrogen line frequency, 11420.405 MHz. But the WOW signal's frequency, while close, had a measured value slightly offset from this, which the comet hypothesis needs to explain. More problematically, the bandwidth of the WOW signal was extraordinarily narrow, narrower than any known natural astrophysical source. Natural sources of radio emission at 1420 MHz produce signals across a range of frequencies due to the Doppler motion of the emitting hydrogen atoms. The WOW signal's bandwidth was far below what a comet's coma would produce. It was in fact consistent with a transmitter, a device producing a pure, narrow-frequency signal, but not with a diffuse natural source. Additionally, the Big Ear telescope's two-beam architecture should have detected a comet, which moves relatively slowly across the sky, in both beams, not just one. A comet in the beam would have persisted long enough to appear in both receivers. The WOW signal appeared only in one. The comet hypothesis is not dead. Its proponents continue to argue for it, but the majority of scientists who have examined it carefully have not found it convincing. The signal remains unexplained. There was another moment, decades later, when the story of the WOW signal took a strange and beautiful turn that most people do not know about. In 2012, on the 35th anniversary of the detection, a group of astronomers decided to send a response. The National Geographic Channel and a science team used a powerful radar transmitter in Florida, the Arecibo-like facility at Evapatoria in Ukraine, directed through a partnership, to send a radio message toward the coordinates of the WOW signal. The message consisted of 10,000 Twitter responses solicited from members of the public, combined with names, pictures, and a musical piece, encoded in a digital format and transmitted into space. The project was called A Message from Earth. It was partly symbolic. No one knew if there was anything to receive it, and partly a genuine scientific gesture, the logical completion of a communication loop that the WOW signal, if artificial, had opened. The message is out there now, traveling toward the Sagittarius constellation at the speed of light. It will take decades to reach wherever the WOW signal came from, if it came from anywhere. We will not receive a reply to that reply for generations at minimum, even if there is something to reply. This is one of the deep and humbling realities of any attempt at interstellar communication. The speed of light is not fast enough for conversation. It is barely fast enough for a message. The gulf between stars is so great that any exchange of information takes centuries or millennia. Whatever civilization sent the WOW signal, if a civilization sent it, may not have even existed long enough to still be there when a reply arrives from Earth. This connects to one of the deepest questions the WOW signal raises, which is not just whether the signal was artificial, but what the existence of an artificial signal would imply about the universe we live in. The Fermi paradox, named for the physicist Enrico Fermi, who posed the question informally over lunch with colleagues in 1950, asks why, if intelligent life is common in the galaxy, we have seen no evidence of it. The galaxy is old. Stars older than the sun have been around for billions of years longer. Any civilization that developed interstellar travel even 1,000,000 years before us, a tiny fraction of galactic history, would have had time to colonize the entire Milky Way by now, many times over, even at speeds far below the speed of light. And yet we see no colonists. We receive no transmissions. We find no artifacts. The galaxy appears, from where we sit, to be silent. The WOW signal is the one exception. The one moment when the silence broke, for 72 seconds, and something appeared in the data that fit the profile of what a signal should look like. And it has not repeated. The silence closed again. Either it was not what it looked like, or something very strange is happening. Either the most exciting moment in the history of SETI was a false alarm, a comet, or interference, or some other mundane explanation we have not yet identified, or it was real, and the fact that it happened only once, and we have never heard it again, is itself a clue about the nature of whatever produced it. The people who study the Fermi paradox have a term for signals that appear once and never repeat. They call them one-off events. And they are both the most exciting thing SETI could detect and the most frustrating, because a one-off event cannot be confirmed. Science runs on repeatability. You see something, and then you look again and see it again, and the recurrence is what makes you confident the first observation was not a mistake. A one-off, by definition, does not repeat. The wow signal is the ultimate one-off. Exactly the thing that would most tantalize and most frustrate a scientist trying to determine whether it was real. Robert Gray spent years of his life trying to find the signal again. He used his own telescope time and borrowed time on facilities around the world to point toward the Sagittarius coordinates. He wrote a book about the search. He never found it. He remained open to the possibility that it was real. He also remained appropriately uncertain because the evidence demanded uncertainty. This kind of honest, frustrated engagement, years of effort, no resolution, no abandonment, is what responsible science looks like when it is faced with an anomaly it cannot explain. You do not declare victory. You do not declare defeat. You keep looking, and you hold the uncertainty, and you try to be honest about how much you do not know. There is a specific technical detail about the wow signal that is easy to gloss over but is actually one of its most significant features: the narrowband nature of the emission. The signal's frequency was measured to be within a bandwidth of less than 10 kHz. Some analyses suggest it may have been within 1 kHz or even narrower. This is extraordinarily narrow for a radio signal. Natural astrophysical sources of radio emission, pulsars, quasars, the cosmic microwave background, hydrogen and interstellar clouds, all produce emission that is broad in frequency. The emission is spread across a range of frequencies because the atoms and electrons and magnetic fields producing it have a range of velocities and energies, and the Doppler effect and other physical processes naturally broaden the signal. To produce a narrowband signal as narrow as the wow signal, a signal that fits in a tiny sliver of frequency space, requires a transmitter, a technological device designed to produce a specific frequency. Nature does not make signals that narrow. Only technology does. This is perhaps the most technically compelling argument for the wow signal being artificial rather than natural. It is not just that the signal was at the hydrogen line frequency and at the right intensity and had the right shape. It is that the signal was also so spectrally narrow that no known natural process could have produced it. The only explanation consistent with everything we know about physics is a transmitter. And the only transmitters we know of are made by intelligent beings. This does not prove the signal was extraterrestrial. A terrestrial transmitter could produce a narrowband signal, but we have been over the problems with the terrestrial explanation. And the combination of all the features, the frequency, the intensity, the shape, the bandwidth, the direction, stacks up into something that is very difficult to account for with any non-artificial, non-extraterrestrial explanation without invoking coincidence after coincidence after coincidence. Eamon knew this. He said in an interview years after the discovery that if you set out to design the ideal signal to distinguish a genuine extraterrestrial transmission from background noise, you could hardly improve on what the Big Ear detected on August 15, 1977. That is both an exciting thing to say and a deeply sobering one, because if the most technically perfect possible signal can be detected once and then never confirmed, it suggests that either we were incredibly unlucky, the signal was real and we just happened to miss it every subsequent time we looked, or the universe is very good at producing things that look like what we are searching for but are not actually that. The uncertainty is the hardest part to sit with. In nearly every other domain of science, uncertainties resolve. You do more experiments, you build better instruments, you collect more data. The anomaly either turns into a discovery or turns into a known artifact. The wow signal has resisted resolution for nearly half a century despite sustained effort from smart, serious people using increasingly powerful equipment. It has not been explained, it has not been confirmed. It sits in the literature like a splinter, too small to remove cleanly, too sharp to ignore, present every time the question of life in the universe comes up. There is something almost unbearably poignant about the way the story ends. Jerry Eamon found the signal on a printout at his kitchen table. He circled it in red pen. He kept going through the printout. The telescope kept listening. Nothing came back. He spent the rest of his life being careful about what he claimed, being honest about what he did not know, being a scientist about it even when the public wanted him to just say yes, it was aliens. He died in 2020. He never knew what it was. He never got to know. The red pen circle in the margin of a computer printout from 1977 is still the most significant piece of data the search for extraterrestrial intelligence has ever produced, and the man who made it never got his answer. The Big Ear telescope itself is gone. Ohio State University demolished it in 1997, sold the land to a golf course. The telescope that found the most intriguing potential signal of extraterrestrial origin in human history was torn down to make room for a fairway. There is a small historical marker on the site. The printout with the red pen circle is in an archive. The signal is out there, or it is not. We cannot say. What happens next in this story depends on technology and time and luck, as it always has. The next generation of radio telescopes, the Square Kilometre Array in South Africa and Australia, which will be the most sensitive radio observatory ever built, capable of detecting signals orders of magnitude fainter than anything previous instruments could find, may survey the sky in directions and its sensitivities that would either confirm or decisively rule out many potential natural explanations for the WOW signal. The broader SETI enterprise has grown considerably since 1977, with programs like Breakthrough Listen funded by tech billionaire Yuri Milner, bringing dedicated telescope time and modern signal processing to the search on a scale that would have been unimaginable in the Big Ear era. If the signal recurs, and if any of these programs happen to be observing that patch of sky at the right moment, they will catch it with a resolution and sensitivity that dwarfs what the Big Ear could manage. But catching it requires it to recur. And it has not recurred in 47 years, and nobody knows why. The WOW signal sits at the intersection of the two questions that human beings find most compelling about their place in the universe. Are we alone, and are we paying attention? For a species that has been looking at the night sky and wondering for as long as it has existed, that has built temples oriented to the stars, and navigated oceans by them, and sent probes past them, and built machines to listen to them, the possibility that the sky once spoke back for 72 seconds, in a voice that fit every criterion we had specified in advance, and that we heard it and circled it in red pen and then never heard it again, is almost too much to hold. It may have been nothing. A comet's hydrogen cloud, a satellite violating the protected frequency band, a glitch in the data encoding that no one has identified, a coincidence of atmospheric conditions that produced a one-time amplification of a weak terrestrial signal. There are enough uncertain links in the chain that none of these explanations can be fully dismissed. Science has been fooled before by extraordinary-looking data that turned out to have mundane causes. The history of SETI is full of signals that excited observers and then evaporated under scrutiny. The WOW signal has lasted longer than any of them, but longevity in the face of failed explanation is not the same as confirmation. And yet, the bandwidth was so narrow, the frequency was so exact, the intensity was so high, the shape was so clean, the direction was toward a patch of sky with no obvious candidate source. Every box that had been defined in advance as marking a genuine signal of extraterrestrial origin was checked. Every one, by a signal that lasted 72 seconds and was never seen again. We do not know what it was. That is the honest answer, and it is the only answer the evidence supports. We do not know. A retired professor sitting at his kitchen table in Ohio noticed something in a column of computer printout data, circled it in red pen, wrote a single word in the margin, and that word has been asking a question of us ever since. The question is not, as it is sometimes framed, simply whether the signal was aliens. The question is bigger than that. The question is whether the universe contains other minds, other instances of whatever peculiar, fragile, improbable thing it is that notices the sky and wonders what is there and builds instruments to listen and keeps listening even when the answer is silence. Whether the capacity to ask questions and look for answers is a singular accident that happened once, on this small planet, and will never happen again. Or whether the galaxy is full of listeners, most of them hearing only silence too, some of them perhaps having sent a single bright pulse into the dark and waited, as we wait, for something on the other end to notice. For 72 seconds in August of 1977, a radio telescope in Ohio heard something from the direction of Sagittarius that might have been the other end noticing, or it might have been nothing. We genuinely do not know. And the not knowing, held carefully, honestly, for almost 50 years, is itself one of the most extraordinary things about the story. The signal said wow. The universe has not said anything since, and we are still listening. We will keep listening. That is what the story means, in the end. Not that we found something and then lost it, though maybe we did. Not that the universe spoke and then went silent, though maybe it did. but that the kind of creature that circles things in red pen and writes one word in the margin and spends the rest of its life being careful about what it claims. That kind of creature, fragile and stubborn and honest, sitting at a kitchen table in Ohio with a stack of computer printout and a cup of coffee, genuinely trying to find out whether anyone else is out there, is the kind of creature that will not stop looking. No matter how long the silence lasts, no matter how many times the follow-up observations come back empty, no matter how many years go by with no second signal and no explanation, we pointed the instruments at the sky in 1960. We have been listening ever since. We found one thing we cannot explain, and we are still there, dish pointed up, waiting for the sound.